Hello students, today we will deal with liquid crystals. As we know that there are three forms of matter. This is gas, solid and a liquid. When we convert solid into liquid, it is not a direct process. When solid is heated to certain temperature, it converts into liquid. There is an intermediate phase, and that intermediate phase is known as liquid crystals. Liquid crystals are those mesophases, that is the intermediate phases in between solid and liquid, which are temperature stable. It means they are thermodynamically stable at a particular temperature. It means when the solid is heated at a particular temperature, then there are some stable states which are thermodynamically stable, and these thermodynamically stable states are sometimes known as mesophases. Liquid crystals are one of the type of these mesophases. Liquid crystals generally have some basic properties. They are organic in nature. It means the only organic compounds can form mostly liquid crystals. Secondly, the property of liquid crystals are displayed only by those organic compounds which are rod shaped. It means this is the second property. Liquid crystals should be organic in nature and they should be rod shaped. Third property of liquid crystal is that they are polarized in nature. It means the organic compounds which we are using to prepare liquid crystals, they have a positive pole and they have a negative pole, and with a rod shape. It means we can show them with an oblique rod shape compound, and the compound is organic in nature. It depends on the temperature whether the liquid crystal will appear as in symmetric phase or nematic mesophase, or the third type is cholesteric mesophase. Liquid crystals are founded in three type of symmetric, nematic and cholesteric mesophases, and these mesophases depends upon the temperature at which we convert solid into liquid, and this temperature will decide whether the liquid crystal will be in symmetric phase, nematic mesophase or cholesteric mesophase. Let us discuss the first mesophase, that is known as symmetric mesophase. Liquid crystals are said to be in symmetric mesophase when all the organic compounds which are rod shaped and polarized are in layers. In case of symmetric mesophase, it is assumed that the liquid crystals is or the organic compound or the molecules are in the form of layers, and each rod shaped molecule of the symmetric mesophase are aligned such that their bigger axis, or you can say that the long axis, as we are seeing that there are two axes, symmetric axis, one is a small axis and another is long one. All molecules are aligned according to that they all the long axes are parallel to each other, and also we are seeing that they are perpendicular to the plane in which they are lying. If this is the plane, then all the molecular long axes are perpendicular to this plane, and every layer have the particles or the molecules of the organic compound in such a way that the second layer is also the molecules having the same long axis direction. This direction can be changed with the help of temperature. We know that as the temperature increases, the motion also increases in between the particles. And the second factor by which we can change the angle in between the plane of the layer and the long axis of the molecule with the help of applied electric field. If we apply an electric field from outside of this material, then we can change the angle in between the two planes. Third one, the factor which can change the angle in between these two vector quantities, that is magnetic field. It means the angle in between the plane and the long axis depends upon these three factors. If we change the temperature, if we change the electric field, or the third one, if we change the magnetic field, we can make a difference in between the angle. It depends whether they inclined in left hand side direction or whether they inclined in the right hand side direction. It depends whether you are giving, it depends upon the direction of the applied electric field and magnetic field. And due to the arrangement of the molecules and the angle in between the planes and the long axis, these symmetric molecules or liquid crystals have a slippery nature. These two layers are like that one layer start to slip on the another layer. The next phase is nematic mesophase. In this phase, again, all the long axes are in same direction, but now we are seeing that in the diagram that long axes are parallel, but the arrangement is not symmetric. In this case, all the molecules are symmetric, but in this case only the long axes are in the same direction, but the molecules are randomly arranged, not randomly rotated, they are randomly arranged. Hence the nematic has not slippery as the symmetric one. It may we can change the symmetric mesophase into the nematic mesophase with the help of these applied factors. If we change the temperature, if we change the electric field and magnetic field, we can change the symmetric mesophase into nematic mesophase. The third one which we are going to discuss is the cholastric mesophase. In case of cholastric mesophase, again we are considering that the molecules are arranged in layers, but in the layers the all directors, that is the long axis direction, is not the same. For example, let us consider if this is my reference line, and according to this reference line I am considering the direction of my long axis of the rod shaped polarized organic molecules. Let us consider now in this layer the molecules are lying such that the angle in between the long axis and the direction of reference is 90 degree. In case of, let us consider this is our first layer, and in second layer if the mesophase is cholesteric in nature, the second layer have molecule adjusted such that the layer having long axis direction like this, in second layer we find out that the direction will start to move according to the increasing number of layers, and we find out that the long axis is making different angles with the reference line. And let us consider in our third layer, the molecules are again perpendicular to the reference line but in opposite direction as compared to the first layer. If we find out that we are observing that with the reference line we are finding out that we are moving in a helical path like a spring, as the spring is moving forward also giving a circular direction. This is known as helical path. In cholesteric mesophase we can find out the color of our organic compound or our liquid crystal depending upon this circle and the distance at which the circle one rotation is completed. As we know that if we are considering both the motion circular as well as linear, then there is a physical quantity which is known as pitch, and it is the distance which we cover in one circular rotation. Let us consider when these long axis directions are moving like this in the upward direction and the circle is completing here, then this is my pitch, and this pitch decides the color of my liquid crystal which is in mesophase. The pitch of this liquid mesophase changes with the change of temperature. Again, if we change the temperature, the pitch, it means the angle of the director with the reference line is changing, and due to which this distance is changing, and due to the distance change, inverse circular rotation, that is change in pitch, we find out the change in the color of our liquid crystal. And this is the property due to which the liquid crystals are used in liquid crystal displays. And this property is you make eligible the liquid crystal to use as in to measure the temperature, and we can use it in thermometers. When the temperature of the cholesteric mesophase change, then the thermometer color will give us the amount of the or the magnitude of the temperature. Hence we can also use to find out we can also use the LCDs with in watches also. Hence they are very useful, and so because of these effects there are many advantages of the liquid crystal. They are very cheap and we can make it of any size, and with the help of these we can use in televisions, as nowadays we are talking about LCDs, that is liquid crystal display units. But there are some disadvantages of LCD also. We have a small range of temperature in which we can operate them. The range of temperature operation on the LC, that is liquid crystal, is very small. Hence we can't use the liquid crystals for long ranges of temperature. Hence we can find out that we can measure the temperature for only the small temperatures or a minimum range of temperatures. Second, they are very time consuming. It is a very time consuming process. It takes very long time to deal with liquid crystals. Their operating time is very large. And third one, they are easily damaged. If the temperature is not controlled, then we can change the cholesteric mesophase into the nematic mesophase, and we can't get the Bragg's reflection condition. Because of Bragg's refraction condition changes, that is the light which are coming with the help of these organic compounds. Let us consider, if this is my cholesteric mesophase and we are applying some sort of wavelength on these, and they are reflecting back reflecting back some some incident light. This reflected light depends upon the pitch of our cholesteric mesophase, and if we change the temperature, it means we are changing the pitch, and if we are changing the pitch, it means we are changing the color which is coming to our eye. And on increasing the temperature, we are converting the cholesteric mesophase into the nematic mesophase, and hence we are just changing the color. And if we increase the temperature up to a certain level, then we will lose the property of liquid crystal, and we cannot no more use the liquid crystal.